Hello everyone, welcome to your physics class of class 8. I hope you all will be fine. Students, in my previous video, I have given you answers of question number from 1 to 26. Now today in this video, I will give you the remaining answers and also we will start next lesson number 6. Okay, so let's begin our class. Question number 27. What do you understand by the focus and focal length of a spherical mirror? Show them on the separate diagrams for each of a concave mirror and a convex mirror. So first focus for concave mirror, as you can see in this picture, you have to draw this diagram, is a point on the principal axis at which the light rays incident parallel to the principal axis after reflection from the mirror. You can see here this is a ray parallel to the principal axis, and this ray after reflection passes through the point F. This point is known as focus, and focal length is the distance between the focus and the pole, that is FP is the focal length. Now focus for convex mirror. For a convex mirror, focus is a point on its principal axis at which the light rays incident parallel to the principal axis appear to meet after reflection from the mirror. As you can see here in this diagram, this is focus for convex mirror, and focal length is the distance between the pole and the focus, that is FL. This is focal length, P and F, the distance between pole and the focus. Now question number 28. Draw suitable diagrams to illustrate how a beam of light incident parallel to the principal axis is reflected by a concave mirror and a convex mirror. So this is a diagram for concave mirror and this is a diagram for convex mirror. This you have to draw in your notebook. Now question number 29. How is a spherical mirror used to converge a beam of light at a point? Name the type of mirror used. So if a parallel beam of light is incident on a concave mirror, it converges a beam of light to a point called focus. Okay, you have to draw this diagram. The type of mirror is concave mirror. Question number 30. How is a spherical mirror used to diverge a beam of light from a point? Name the type of mirror used. So this is a diagram, and in case of convex mirror, the reflected rays diverge and do not meet at a point after reflection. They appear to come from a point F on the principal axis. This is the point F, and the type of mirror used is convex mirror. Question number 31. State the direction of the incident ray which after reflection from a spherical mirror gets reflected along its own path, and give a reason. So this is a diagram that you have to draw. A ray passing through the center of curvature is incident normally on the spherical mirror, gets reflected back along its own path. As you can see here, a ray passing through the center of curvature is reflected along its own path in case of a convex mirror also. Now question number 32. What is the focal length of a spherical mirror related to its radius? How is the focal length of a spherical mirror related to its radius? So focal length is equals to radius of curvature divided by 2. Question number 33. The diagram given below shows two parallel rays, 1 and 2, incident on a concave mirror and a convex mirror. Draw the reflected rays and mark the focus by the symbol F. So answer is this one. You have to draw this diagram for concave mirror and also for convex mirror. Okay. Now question number 34. Complete the following diagrams in figure by drawing the reflected rays for the incident rays 1 and 2 if the focus, if F is a focus and C is the center of curvature. Okay. So this is the answer for this one. This is a ray that passes through focus and this is a ray that passes through center of curvature and gets reflected back along its own path. A ray passing through F after reflection becomes parallel to the principal axis, as you can see here, and ray 2 passing from center of curvature travels back, that is retraces its path, that is reflected back along its own path. Now for convex mirror, this is a diagram and you have to draw this diagram, and you have to write ray 1 becomes parallel to principal axis, ray 2 replaces its path, that is reflected back along its own path, same way as in case of concave mirror. Now question number 35. Which of the two convenient rays that are chosen to construct the image of by a spherical mirror for a given object? Explain with the help of suitable ray diagrams. So for answer, you have to write this point. A ray passing through the center of curvature is reflected along its own path, and you have to draw this diagram, that is figure number 5.22. And then second is a ray parallel to the principal axis, which after reflection passes through the point through the focus, and also you have to draw this diagram. Okay, now next question. Draw a ray diagram to show the formation of image of an object placed beyond the center of curvature of a concave mirror, and state the position, size and nature of the image. Means you have to draw the diagram to show the formation of image of an object placed beyond the center of curvature. Okay, so you have to draw this diagram, and the nature of image is real inverted smaller image is formed between the center of curvature and focus, and position is between C and F, center of curvature and focus, and size is smaller than the object. Question number 37. Draw a ray diagram to show the formation of image of an object placed at the center of curvature of a concave mirror, and state the position, size and nature of the image. So this is the diagram, and the nature, the real inverted image of the same size is formed at the center of curvature, and this A and B dash, A dash and B dash is at the center of curvature, means this is the image of the object AB, and size is equal to the size of the object AB, and it is inverted and real. Question number 38. Draw a diagram to show the formation of image of an object placed between the focus and center of curvature of a concave mirror, and state the position, size and nature of the image. So this is the diagram for this answer, and the nature is a real inverted and magnified image is formed beyond the center of curvature, and also you have to write this one. Now question number 39. Draw a ray diagram to show the formation of image of an object placed between the pole and the focus of a concave mirror, and state the position, size and nature of the image. So this is the diagram, and this is the nature of the image formed after reflection. Virtual, erect and bigger image is formed behind the mirror, and image formed is A dash B dash, as you can see here, and it is magnified, size enlarged or magnified, and virtual and erect images formed. Question number 40. Draw a ray diagram to show the formation of image of an object placed on the principal axis of a convex mirror, and state the position, size and nature of the image. What happens to the image as the object is moved away from the mirror? So this is the diagram. I already explained you this in while explaining the lesson, and also you have to write down the characteristics of the image. So when the object place the object anywhere in front of the convex mirror, image formed is between the focus and pole, size is diminished, nature is upright and virtual, and as the object is moved away from the mirror, the image shifts towards the focus and decreases in size but is diminished. That is diminished. Okay, so this is that is. Now question number 41. Draw separate diagram for the formation of virtual image of an object by concave mirror and convex mirror, and state the difference in the two images. For convex mirror, you have to draw this diagram. Okay, and for concave mirror, you have to draw this diagram. Okay, this is answer number 1 for concave mirror and for convex mirror. Now question number 42. Name the mirror which always forms an erect and virtual image. What is the size of the image as compared to that of the object? So it is a convex mirror. The size of the image is smaller than the size of the object, but when the object is at infinity, the size of the image is point size. Question number 43. Name the mirror which forms an erect, virtual and enlarged image of an object. What is the position of object relative to the mirror? Concave mirror forms an erect, virtual and enlarged image of an object. Since convex mirror always form virtual, diminished, and erect image. The position of the object between focus and pole of the mirror as shown in the figure in answer number 39. Question number 44. What is a real image? Name the mirror which is used to obtain the real image of an object. What should be the position of the object relative to the mirror? Answer. When rays of light after reflection or refraction actually meet at some other point, the image is real, and the answer for the mirror is concave mirror, and except between pole and focus, the image formed is real. Now 45 question. How can a concave mirror be used to obtain a virtual image of an object? Draw a diagram to illustrate your answer. So this is a diagram. Okay, virtual, erect, and bigger image is formed behind the mirror. Question number 46. State two uses of a concave mirror. So these are the two uses of a concave mirror, and you can write any other use from the book also. Question number 47. State two uses of a convex mirror. So these are the uses of convex mirror, and if you want to write from the book, you can write from the book also. Now question number 48. A driver uses a convex mirror as a rear view mirror. Explain the reason with the help of a ray diagram. From page number 95, you have to write the answer from here. A convex mirror diverges the incident light rays and always forms a small erect image between its pole and focus. This fact enables the driver to use it as a rear view mirror and to see all the traffic behind. Okay, so you have to write till here and you have to draw this diagram. Okay, this diagram you have to draw. Next question. Question number 49. State the kind of mirror used by a dentist and a street light reflector. So these are the uses of what kind of mirror is used by a dentist? Concave mirror, and a street light reflector, convex mirror. Now last question number 50. Name the kind of mirror used to obtain a real and enlarged image, virtual image and enlarged image, real and diminished image, and virtual and diminished image. So these are the answers for this question. Now the question answers of lesson number 5 here is completed. Now we will start the explanation part of lesson number 6. Lesson number 6 is heat transfer. Okay, we have already discussed in class in your previous class that the sum total of internal kinetic energy and the internal potential energy is called the heat energy of a substance. Okay, so heat is the internal energy of a substance and it is measured as in joule. Okay, so unit of heat is joule. And you know that when two bodies at different temperatures are in contact with each other, heat always flows from high temperature of a body to a low temperature. Means from the body which is at high temperature to a body which is at low temperature. And the average kinetic energy of the substance is a measure of the temperature of the body. Now, when there is a rise in the average kinetic energy of molecules of a substance, its temperature increases. Means when the kinetic energy of the molecules of a substance increases, its temperature increases, and when there is a fall in the kinetic energy of the molecules of a substance, its temperature decreases. Now, effects of heat. What are the effects of heat? There are three main effects of heat. Means first is heat change in temperature of the body, and heat changes the state of the body, and heat changes in the size of the body. So first one is change in temperature of a body. Now when a body is heated, its temperature rises, and when the body is cooled, its temperature falls. You already know this, that when the temperature increases, rises, then when the body is heated, its temperature rises, and when the body is cooled, its temperature falls. Now the change in the temperature of a body depends on the two factors. Now what are those factors? The quantity of heat that is imparted or rejected from the body, means the amount of heat that is imparted to the body or rejected from the body. So change in temperature of a body depends on the quantity of heat Okay, means if we impart heat to a body, the temperature rises, and if the heat is rejected from the body, its temperature falls. Now, why this happen? Because when we heat, the molecules begin to move faster and its average kinetic energy increases and the temperature rises. On the other hand, on cooling, the average kinetic energy decreases, of the molecules decreases and the temperature fall. Now, second is material of the body. Means some materials rise to a high temperature, while some to a low temperature, even when the same quantity of heat is imparted to them. Means even though the same amount of heat is imparted to the bodies of that is made up of two different material. So the in some materials, in some cases, the temperature rises to a higher temperature, means the temperature rises to a higher point than some other if the body is made up of some other material and the same amount of heat energy is imparted to them, then the temperature rises to a lower level. Okay. So therefore, when the materials are made up of, when the body is made up of different material, there is some material rise to a high temperature, while some to a low temperature, even when the same amount of heat is imparted to them. Now the different is why the difference is there, because of the specific heat capacity of that material. Okay. Second is change in the state of the body. Matter exists in three states, that is solid, liquid and gas. You already know this. And the process of change from one state to another, that is from solid to liquid or from liquid to gas at a constant temperature, that is known as change of state. Now solid at when solid is heated, it changes to liquid, and when liquid is heated, it changes to gas. Now reverse, when reverse happens, means when a gas gets cooled, it changes to liquid, and when a liquid is cooled, it changes to solid. Means when heat energy is absorbed by a solid, it changes to liquid, and that is known as melting. When a liquid is heated and it changes to gas, that is known as vaporization or boiling. And when a gas rejects heat, okay, when heat is rejected by gas, means when it is cooled from gas to liquid, that is known as condensation. And when heat is rejected from liquid and it changes into solid, that is known as freezing. As we can take the example of ice. When ice absorbs heat, when ice is heated, it changes into water, that is it melts to form water. When water is heated, it changes to water vapor, or we can say steam. When steam gets cooled down, it changes to liquid, and when liquid freezes, it forms ice. Okay, that is known as freezing. So uh, this is the change of state. Okay, when solid changes to from solid to liquid, that is known as melting. When liquid changes from liquid to gas, that is vaporization. When a gas changes to liquid, that is known as condensation. And when a liquid changes to solid, that is known as freezing. Now, water at 0 degrees Celsius, sorry, ice at 0 degrees Celsius forms water, and same way the water freezes at 0 degrees Celsius to form ice. Okay, same way liquid, that is water, at 100 degrees Celsius on heating at 200 degrees Celsius vaporizes into steam, and at 100 steam at 100 degrees Celsius on cooling condenses to water, means the fixed temperature is 100 degrees Celsius. Okay, now when a solid changes directly from its into its vapor, that is at a fixed temperature, that is known as sublimation. Means solid without changing to liquid directly changes to gas, that is known as sublimation. An example is camphor. You all must have seen this. And camphor directly changes from its solid state to vapor state. Okay, and these vapor on cooling changes directly into solid state, and this process is known as solidification. Now the heat absorbed during the change of state is called latent heat or hidden heat, because it is not manifested by any change in temperature. Means temperature does not change, only the state changes. This heat, when expressed for unit mass of a substance is called specific latent heat. Okay. Now, since the temperature does not change during the change of state, there is no change in average kinetic energy of the molecules, because there is no change in the temperature. Only the state changes, and but the heat absorbed changes the average potential energy of the molecules of the substance, and therefore the state changes. Now, change in size of the body. Third effect of heat is change in size of the body. When a body is heated, it expands, and when it gets cooled, it contracts. Means this change in size of the body is due to heating, that is called as thermal expansion. Means when a body is heated, when heat is supplied to a body, it expands, and when it gets cooled, it contracts. And this change in size of a body due to heating, means either it contracts or expands or contracts. This is known as thermal expansion. All solid, liquid, and gases expand on heating and contract on cooling. Now, why this happens? Because the average intermolecular separation between the molecules of a substance increases on heating, while on cooling it decreases. Okay, means the separation between the molecules increases on heating, and on cooling it decreases. That's why the size of a body changes. Okay, so this is the third effect of heat. So you have to read this lesson up to here, and also you have to complete your work, those question answers of lesson number 5 in your notebook, and further explanation of the lesson I will give you in the next video. Thank you.